Hello mga kasamas! We're back again for another math journey. And this time, let's discuss one of the problems in the arithmetic series I've presented to my grade 10 students. And here's the problem. The sum of the first 50 terms of an arithmetic series is 200. And the sum of the next 50 terms is 2,700. Find the first term. As we can see, we can only get limited information about from the problem. And the two informations that it the two information that is given in the problem is one, the sum of the first 50 terms of the arithmetic series is 200. Let me underline that one. So the sum of the first 50 terms is 200, which can be written as S sub S sub 50 is equal to 200. And the second one is the sum of the next 50 terms is 2,700, which can be written as S sub 51, since after the 50th term, so sub 51 to 100 is equal to 2,700. And in this problem, in order to solve for the first term, we need to solve first for the common difference, d, by forming two equations out of the given. Then, we're going to use any algebraic methods to solve for d, such as elimination or substitution. Well, whatever method is best to apply. But let's see if we can show both methods here. So let's go. For the given S sub 50 equals 200, we'll have, let me write first the sum formula. So we have S sub n is equal to n over 2 times the quantity 2a sub 1 plus the quantity n minus 1 times d. So we'll have S sub 50 is equal to 50 over 2 times 2a sub 1 plus the quantity 50 minus 1 times d. And let's simplify this. So we know that S sub 50, or the sum of the first 50 terms, is equal to 200. So we'll have 200 equals 50 over 2, or we have 25 times 2a sub 1 plus, and 50 minus 1 is equal to 49d. Then notice that we can divide both sides by 25. So let's divide both sides by 25 to simplify the equation. Then we can cancel out 25 here, and 200 divided by 25 is equal to 8, and we'll have 2a sub 1 plus 49d. And this is now our first equation. So let's denote this one as equation number 1. And after this, um, let's form the second equation using the second given, which is s sub 51 to 100, which is equal to 2700. But this one is a little bit of a challenge. So let's try to illustrate this first. All we know is that the sum of the terms from 51 to 100 is 2700. So to form an equation using this information, first we need to get the sum of the terms from 1 to 100. Then, subtracting the sum of the first 50 terms, denoted by S sub 50 equals 200, equals the sum of the next 50 terms from 51 to 100. And that is denoted by S sub 51 to 100 is equal to 700. Thus, our mathematical statement would be S sub, oh, wait. So our mathematical statement would be S sub 51 to 100 is simply equal to the sum of the 100 terms minus the sum of the first 50 terms. And now, let's form the equation. So, the sum of the terms from 51 to 100 is 2700. So this will be 2700 is equal to, and the sum of the 100 terms will be defined by 100 over 2 times the quantity 2a sub 1 plus the quantity 100 minus 1 times d, and then minus the sum of the first 50 terms defined by 50 over 2 times the quantity 2a sub 1 plus the quantity 50 minus 1 times d. Okay? And then let's simplify this. So we have 2700 equals 100 over 2 is simply equal to 50 times the quantity 2a sub 1 plus 100 minus 1 is equal to 99 d, and then minus, and 50 over 2 is simply equal to 25 times the quantity 2a sub 1 plus 50 minus 1 is equal to 49 d. Okay, and On the right hand side of our equation, observe that there is a common factor 25, right? Because this part can be considered as one term and this one is another term, where 50 and 25 can be regarded as their uh, numerical coefficients. So let's remove the common factor between 50 and 25, and that is 25. But let's write first, or rewrite first, 2700 here, and then let's remove the common factor 25. So we're going to use braces here. So removing 25 as the GCF means we divided 50, or we are going to divide 50 and 25 by 25. So 50 divided by 25 is equal to 2, and let's rewrite 2a sub 1 plus 99d, and the 25 here divided by 25 is simply equal to 1, so we have minus 2a sub 1 plus 49d. And since we remove 25 as the common factor, that means we can divide both sides by 25, since 2700 I think is divisible by 25 as well. So let's divide both sides by 25, and 2700 by 25. So we can cancel 25 here, and 2700 divided by 25, we have let's see, 2700 divided by 25 is 1, 25, 2, 20, so 0, so bring down 0 to 100, and we have 8. So we have 108 is equal to I think we can simplify this out, right? We have 2 times 2a sub 1, so we have 4a sub 1 plus 2 times 99d, so we have 99 times 2, we have 18, and we have 198d. And let's simplify the second expression by distributing the negative sign inside the brackets. So we have negative 2a sub 1 minus, we have 49d. Okay, I think we're almost there. And let's simplify this equation by combining like terms. So we have 108 is equal to 4a sub 1 minus 2a sub 1 is equal to 2a sub 1, and 198d minus 49d is equal to 100 let's compute. 198 minus 49, so we have 18, so 9, so we have 8, so 49, so plus 49 Is it 14? 149D, I mean. 149D. And let's erase this first. And this will be our second equation, or equation number 2. Okay, so let's make some working space. So we have now the two equations here. The next step is that we're going to solve for the common difference, or D, using, I think the best algebraic method here is the elimination method. So let's subtract equation 1 from our equation 2. So we'll have, oops, wait, 108 equals 2a sub 1 plus 149d and minus 8 equals 2a sub 1 plus 49d. And let's remember that when subtracting polynomials vertically, we need to change the signs of the subtrahend. Thus, the term containing a sub 1 here will be cancelled out later. So this becomes negative 8, and this becomes negative 28, and this one becomes negative 49d. Okay? And 108 minus 8 is simply equal to 100 equals 2a sub 1 minus 2a sub 1 becomes 0. So we can cross this out. And 149 minus 49 is equal to 100d. Then to solve for d, let's divide both sides by 100. Okay? Then cancel this out, and 100 over 100 is equal to 1, which is our d. Okay, so we have now the value of d, and we're going now to solve for the value of a sub 1, or a sub 1. And to solve for a sub 1, we can use either equation 1 or equation 2. However, it's more convenient to use equation 1 since the terms involved are smaller numbers compared to equation number 2. So let's substitute 1 for d in equation number 1. Hence, we'll have 8 equals 2a sub 1 plus 49d. And our d now is equal to 1. So we have 8 is equal to 2a sub 1 plus 49 times d, which is equal to 1. And we have 8 is equal to 2a sub 1 plus 49. Then let's transpose 49 to the left side, or simply subtract 49 both sides. we can do it this way too. So 8 minus 49 is equal to um, negative 41, and 49 minus 49 here becomes, sorry, 0. So we'll have 2a sub 1. And to solve for a sub 1, let's divide both sides by 2. And we can cancel out 2 here. Therefore, the value of our a sub 1 is equal to negative 41 over 2. Okay? So, I think we already answered the question, the value of a sub 1. And that is negative 41 over 2, or when expressed as a decimal number, I think that's negative 20 over 20.5. Okay, but preferably we express this one as a fraction. Okay, so that's our solution for this problem, and I hope you learn on how to solve problems where the given are simply the sum of the first few terms and then another few terms in the sequence. So all we need to do is to form two equations out of the given, and then we can use algebraic methods to solve for D and then solve for A sub 1. So that's all for today mga kasama, and enjoy learning mathematics. Goodbye!